Hello everybody, I will start my today another live coding session. So in my today's video, I will solve this question. Validate binary search tree. Given the root of the binary tree, determine if it is a valid binary search tree. A valid binary search tree is defined as follows. The left subtree of a node contains only nodes keys, strict tree less than nodes key. The right subtree of a node contains only nodes with keys, strict tree greater than the nodes key. Both the left and right subtrees must also be binary search tree. Okay. So let me firstly clarify my understanding of this question. So in this question, let me clarify the interface. So in this question, I will be given the root, which is the tree node. Then I will return Boolean, which represent if the given tree node, given binary tree is the binary search tree. Okay. And let me check some constraints. So my first thing I'm wondering is if root can be known or not. And this is no, because the number of nodes is at least 1. Yeah. Aside from that, I have nothing I'm wondering. Root of value of the each node. I think it doesn't matter that much. Yeah. In this question. It's pretty fine. Okay. Let me take an examples. So let's say I'm given this root node 1 and the tree looks like this. Yep. In this case, I should return true. And maybe this is more like the edge case, but if there is only one node, I should return true. And let's say when the node, tree looked like this, this is not binary search tree because here the node value is 1 and so sorry, this is not binary tree actually. Let me change it. So okay, so this is binary tree. So first tree, left subtree of a node contains only nodes with keys strictly less than nodes key. This is true for 4 and 2, 3, 1, and 5, 6. Sorry. Or I should take a look at this recursively. So for this 1, this is binary search tree. For 1, 2, 3, this portion 2 is larger than 1, and 3 is larger than 2. So this 1, 2, 3 is binary search tree. And same thing can be said to 5, 6. And for this 4, left tree is binary search tree, and right subtree is also the binary search tree. And also I can say every values in 1, 2, 3 are strictly less than 4. And every value which are inside of 5, 6, left subtree are strictly larger than 4. So I can say this is a binary search tree. But say let's take a look at in this case. In this case, when I take a look at node 4, right subtree and left subtree are binary search tree. But for the right subtree, all the nodes are not directly larger than the root node 4. So this is not binary search tree. Okay. So I think I'm almost finding the solution here. So basically what I should do is do the recursion. Yeah. Recursively check if it binary search tree. And also for each recursive function, it should return minibar in the current subtree and maxbar in the current subtree. And so let's say I'm taking root node 2 and I return that minibar and maxbar to node 4. And what this node 4 does is, because node 2 is the right subtree, it will check max value from the left subtree is smaller than the root dot var. If this is true, I can say this part is okay. If not, I will return false from this recursion. And also I will update the min and max with these values. I actually don't have to update, but I can update. It is fine. It doesn't take, it takes only the constant time and not hard at all. Okay. So that being said, the recursive function, the interface should look like this. Yeah. And this should return Boolean and minibar and maxbar, the tuple of this. Okay. I will implement this. Okay, that being said, I will do the compressed analysis. Assuming that there are n nodes in the given binary tree, the time complexity should be O of n, because each recursive function is called with each node. There should be exactly n recursive function calls, and in the worst case. And for each recursive function, it takes only the constant time, because what I would do is just checking the, minibar and maxbar from the child result with the current root dot var. And also, it will do this is about the Boolean. Yeah. And for minibar and maxbar, I update the return the minibar and maxbar from each of left of 3 and right of 3, and update takes the minibar and maxbar from those and also with root dot var. Yeah. So it takes O of n time. For space complexity, the only data structure I need is the recursion stack, and this is exactly equal to the maximum depth of the tree. So in the case when the tree is just like the linked list, for example, all the nodes are connected as the left subtree, the depth should be n. So in this case, the space complexity should be O of n, which is the worst case. Okay, now let me implement this. So I've written the helper method which returns the tuple. So I just have to call this from the main method and returns the first element in the tuple. Yeah. Here, So the base case is maybe this one. In this case, I can return true. I can say by default, this is binary tree search tree. And for minivar and maxbar, there's nothing here actually. So I will return math.infinity. No, maybe this should be the opposite. Let me check it later when by seeing how this child result, this result is used by the parent recursive function. Okay. So now I'll call this. In this way. So this I can say if this is BST or not by this and this and this. So in this way, I can check if currently this is BST or not. And for this mini, it should be the comparison between left mean, right mean, and root of var. Do the same for max. Then I return the table of this and this and this. Okay. So now I do check line 48. What is expected to be returned if when I call this with num? When I call this is num, left BFD should be true. Left min, this is used as the mini of this. So if this is num in the parent recursive function, I try to complete this left min, which means that I should set infinity. And in that way, this never becomes the mini number for these three numbers. So this is ignored. So yes, I should return mass infinity. And for the third element in the tuple, this is used in this way. So if this should be negative mass infinity, this becomes always true, which is as expected, because this doesn't become the bottleneck. That current root is parent root is binary search tree. It's okay. And also here in line 59, this is expected to be negative infinity. In that way, left max, this value is completely ignored when calculating this max, which is good. Okay. Let me add quickly if what I mean to say is I try to make it as a definition, to which the parent can reference. Okay. That being said, I finished the implementation. So let me walk through my code. I will go with this case. So in this case, root is node 1 and is BST, so this becomes node 1 and root is not known, so I go to line 55 and this should be, because root.left is known, what is returned is true, infinity, negative infinity. The same for root.right. So this is BST. This becomes true and left max, which is negative infinity, which is smaller than root.var, which is 1, yes. And root.var 1 is smaller than right mini, which is infinity, yes. So this is BST, this becomes true. And this min should be mini of infinity, infinity, and 1. So this should be 1. And this this max, this should be the maximum of negative infinity, and root of the bar, which is 1. It should be 1. So this returns true 1, 1. So in line 53, no. In line 47, I return true. Okay. Yeah. Even though I tested only this case, I actually covered all the lines in my implementation. Yeah. And I'm pretty sure this worked as expected. So I'm almost pretty sure that my code is correct. So let me execute. Oh. I should write return here. Okay. Accepted. Great. Yep. Let me quickly write more. I think there are some alternative solutions. Firstly, what I can do is do another traversal and check values are increasing. If this is true, I can return true. Yeah. So maybe I can do it with recursion or with iteration. Yeah. I think these are also possible implementation. Okay. That being said, I finished my today's coding practice. So let me quickly wrap up. So today, I solved this question, which is quite simple. I'm given the binary tree and I will judge if it is a binary search tree and I return the Boolean. So my approach was I used the recursion. I didn't do the traversal. Instead, I did recursion and returned if current tree is BST or not, and also I returned minivar and maxvar of the current subtree. And this can be used in the parent recursive function call. Yeah. So in the end, I can return the final result in the main method. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.